Welcome back for yet again another installment on significant figures. This is the fourth in the video series, and if you've not figured it out by now, this is the big thing for this unit. The integrated kids know this as topic 3D, and what we're going to be dealing with in this one is multiplication and division with significant figures. So let's skip ahead to where we left off. Let's suppose that you're doing a lab, and in this lab you take two measurements, mass and volume, and you use those measurements to calculate density. To do that, you put your object on a scale, and this scale happens to read out to the thousandth of a gram, so you get a piece of data with 5 significant figures. And your volume, you put it in a cylinder, and the cylinder is measured to the 10th of a milliliter, so you get a volume measurement with 3 significant figures. Throw those numbers into your calculator, and your calculator returns this. If we were to follow our rules for significant figures with this number, we would get 9, because we've got a decimal with no placeholders in front, so all the digits count, and there are 9 of them. Of course, there would be more if our calculator had the capacity to show them, so this would have lots of figures after this probably. But the question is, when we report density, should we report it with the same number of significant figures as our best measurement, which had 5 significant figures, as our worst measurement, which has 3 significant figures, or should we just report it with whatever number of significant figures that the calculator returns? And this always makes me think about something that one of my college professors told me, which was garbage in, garbage out. And what he meant by that is if you're doing a procedure and you put low precision numbers in, your answer can't get any better than whatever your low precision numbers are. So when you report density for this lab, it can only be as precise as your least precise measurement, which in this case is our volume, because it only has 3 significant figures. So I'm going to use my calculator's answer, and I'm going to look at it, and I'm going to use the rules for rounding that we discussed in the previous video to round whatever the calculator gives me to 3 significant figures. So I'm going to keep my first 3, 8, 7, 2, and I'm going to look at the next one just to tell me how to round the last one that I'm keeping. 3 doesn't round up, so I'm going to report my answer as 0.872 grams per milliliters, because that has the same degree of precision as my least precise measurement. Skip over this. You guys in integrated are not responsible for addition. And come to our examples here. And again, for the integrated class, we're only going to be looking at these. Chemistry nerdlings, we will come back in a separate video to do this addition and subtraction. So if you're one of the chemistry kids watching this one, look for a part E. I'm working with some limited space on this slide, so I'm just going to write everything down here in this corner and then erase it as we go. So on the first one, 651 times 75, my calculator returns 48,825. I'm going to look at these two. This guy has my lower significant figures. It has 2 significant figures. If you need to go and know how I know the number of significant figures here, you're going to have to go back and watch part B. It'd take all day to go over that for each and every one of these. So anyway, 2 significant figures on that one, 3 and 651. So I'm going to round this to 2 significant figures. My first 2 are the 4 and the 8. This 8, my third significant figure, tells me to round this 8 up. So my answer becomes 49,000 with 3 placeholder zeros. Okay, second problem, 7.835 divided by 2.5. My calculator returns 3.134. This one has the lower number of significant figures. It has 2, so I want to keep the first 2. That's the 3 and the 1. I look at my next one to tell me how to round the 1. Doesn't round up, so my answer is going to stay as 3.1. Number 3, 14.75 divided by 120. Calculator returns 12.2916. Repeating. And 1.20 has my lowest number of significant figures. It has 3. So I want to keep the first 3 significant figures here, the 1, the 2, and the 2. I look at the next one to tell me how to round this one. That rounds up. So my answer becomes 12.3. Okay, number 4, 220 decimal point times 8.1. Calculator returns 1782. This has the lower number of significant figures at 2, so I want to keep the first 2, the 1, the 7. The 8 tells me to round the 7 up, so my answer becomes 1800 with 2 placeholder zeros. The fifth one, 360 times 51 point times 907. My calculator returns 16655.2. 51 has my smallest number of significant figures at 2. This one's also tied at 2. So anyway, we're keeping the first 2, which is the 1 and the 6. The 6 tells me to round the last one that I want to keep up to a 7. And I need 1, 2, 3, 4 placeholder zeros. Don't need the decimal or the 2. If I tack that on there, it'd be significant. We talked about that in the third video on rounding, so my answer is 170,000. Fifth one, 5.18 times 0.77 times 10.22. Calculator returns 40.763492. This guy has my lowest sig figs at 2, so I want to keep the first 2, the 4, and the 0. Look at the next one to tell me how to round the last one I want to keep. 7 rounds up. My answer is 41. Number 7 here, 34.95 divided by 11.169. Calculator returns 3.121968. This has my lower number of sig figs at 4, so I want to keep the first 4. 1, 2, 3, 4. Look at the next one to tell me that doesn't round the 9 up. So 3.129 are my 4 significant figures. And the last one, 7.156 divided by 10 decimal point. Calculator returns 7.7156. 10 with the decimal point has 2 sig figs, so I want to keep 1, 2. 5 tells me to round up. 0.72 would be my final answer. Okay, so this concludes the Sig Fig series for integrated kids. Chemistry nerds, like I said, you've got one more coming up on this. Hope this helps.